Hello students, welcome to Vista's Learning. This is Shruti here, your chemistry tutor. We are in Vista's Learning where you get the quality education for all. Yes students, as we have already studied, we are in 11th standard chemistry and we are doing ahead with the hydrogen chapter, and we have already finished this chapter. Do you agree with that? We have completed this chapter? No. Until and unless we finish the revision or exercise part, not even a single topic will be finished, right? Yes. So this is our lecturing class 7 where we are going ahead with exercise of hydrogen chapter, which is 9th chapter in your 11th class. So we'll just go ahead with this. If you see, you can easily understand this question. Right? What's the question? Write the names of isotopes of hydrogen. Yes, students, what do you mean by isotopes? Isotopes are those which have same number of atomic number but different mass number. How does they vary in mass number? Just the difference in the neutrons. And hence here we have the three types of isotopes. What are they? They are asking. And what is the mass ratio of these isotopes? So hydrogen has how many? 3 isotopes. 1, 2, 3. What is this? All the hydrogen are having the same structure. 1 proton, 1 electron, right? How do they differ? Yes, they do differ by neutrons. They have 1 proton, 1 electron and 1 neutron in deuterium, 0 neutron in protium and 2 neutrons in tritium. If you see protium, deuterium and we have tritium, where here the mass number is 1, 2 and 3 respectively, and hence how do they vary according to the mass, or what is the mass ratio if they ask? What is the answer? It's 1:2:3. As we see 1 proton, so 1 is the mass number for protium. 1 proton and 1 neutron, so here 2 as the mass number, and 1 proton and 2 neutrons in tritium, hence we get 3 as the mass number. That means, what do you mean by mass number? Mass number is equals to number of protons plus number of neutrons present in the nucleus. Got this? Good. How can the production of dihydrogen obtained from coal gasification be increased? So first of all, what is this coal gasification? Students, the process by which while you are producing the syngas from the coal will be called as coal gasification. On destructive distillation of coal, we get the syngas and that is being produced, and that will be called as coal gasification. Around 1000-70 Kelvin, we get this reaction where coal is being subjected to destructive distillation. We get carbon monoxide and hydrogen gas. The production of dihydrogen can be increased. How it can be increased is a question, right? First, the question is that coal gas means what? We need to understand. So we got this, what is coal gas and or coal gasification, and how it is being increased. That is what the question is asking, the second part of the question. So the production of dihydrogen can be increased by reacting carbon monoxide of syngas mixture. This is called as syngas, right? So this mixture with steam in presence of iron chromate as a catalyst. You can see carbon monoxide reacting with water in presence of catalyst. What is the catalyst we are using? Iron chromate. Iron chromate is a catalyst which we are using here at 673 Kelvin. That produces carbon dioxide and hydrogen gas. Hope you are understanding this question, students. I just repeat, when they are asking you the question, how can you produce dihydrogen which is obtained from coal gasification, and how can you increase that yield of dihydrogen? First of all, what is gasification or coal gasification? That is the process by which syngas is being produced by coal, and that will be called as coal gasification. Around 1000 to 1270 Kelvin, we have carbon which is been subjected for destructive distillation, where you can react with carbon, can react with water here, and that produces carbon monoxide. You can also say hydrolysis takes place where carbon reacts with water molecule to give carbon monoxide, and hydrogen will be released. Yes, now hydrogen is being released. How to increase this yield of hydrogen? For that, this byproduct which we got carbon monoxide, we are taking that carbon monoxide in presence of iron chromate as the catalyst. We are reacting this carbon monoxide again with water molecule to get hydrogen. Got it? In presence of 273 Kelvin. At 273 Kelvin, this can be produced. Got it? Next, what characteristics do you expect from an electron deficient hydride with respect to its structure and chemical reactions? So we have studied about electron deficient, electron precise, and electron rich hydrides. So the question is about electron deficient hydride. That means here 13 group elements are reacting with hydrogen. So it is expected to be a Lewis acid. What do you mean by Lewis acid and Lewis base? We have already explained this. Just guess, we'll just come back with that. So for example, if you take diborane, it is a dimer of BH3. As I've already told you, it is a dimer of BH3. So there is a reaction, like attraction between the hydrogen molecules here, which forms the dimer B2H6. That is nothing but, this is one molecule, this is another molecule. They are forming, two molecules are combining together to form dimer. Di means two, mer means unit. Two units are combining together. Two units of barium hydride, boron hydride. Okay, so they form the diborane and forms a complex with lithium hydrogen, which gives you H minus ions. Did you understand what is Lewis base and Lewis acid now? So lithium hydride is reacting with diborane to give lithium borate with the ion of lithium borate, the complex, and with that lithium borohydride. You can see here, this is the Lewis base, this is the Lewis acid. Hope you understand this, students. So you can see this is the Lewis acid, where the Lewis base is lithium hydride. Got it? Next, among NH3, H2O and HF, which could you expect to have highest magnitude of hydrogen bonding and why? That means what they are asking, in presence of NH3, H2O and HF, which is having the highest magnitude. They are not asking which is having more hydrogen bonds. If they ask you which is having more hydrogen bond, then you can think about the hydrogen which is present in the molecules. But they are asking the magnitude of hydrogen bonding. Magnitude means which is a very strong hydrogen bond among ammonia, water and hydrogen fluoride. Can you guess this? Is it ammonia or hydrogen or the water or hydrogen fluoride? For this, you need to know about the electronegativity. We'll just check this answer. The strength of the hydrogen bonding depends upon the magnitude of the polarity of the bond. What do you mean by polarity? From where does it come? It depends on the electronegativity and electropositivity of the molecules or the atoms which is been combining, right? So if you see that hydrogen which is been bonding with nitrogen and which is bonding with oxygen and bonding with fluorine, the hydrogen which is bonded with fluorine has the maximum polarity. As we know, fluorine is the highest electronegative element. So since fluorine is most electronegative element, hydrogen bonding which is present in the hydrogen fluoride is having the higher strength, and hence we can say that hydrogen fluoride is having the highest magnitude of hydrogen bonding. You can see here hydrogen which is been linked with fluorine. There you will be having the electron which is been completely almost towards, like shifted towards fluorine, because fluorine is the most electronegative element. So it will get the delta plus here, delta minus, and that fluorine which is having the higher magnitude of negativity will attract easily the other positively charged or partially positively charged hydrogen, and thus bond will be more stronger than that of the nitrogen or oxygen present in water and the ammonia. Next, compare the structure of hydrogen. Is it hydrogen? Structure of water molecule and hydrogen peroxide. So, as we have already studied about the structure of hydrogen peroxide as well as water, it is easier for you to answer this question, isn't it, students? Yes. In water molecule, what happens? The oxygen will be having sp3 hybridization. This hybridization you will study in your 11th or 12th standard, students. Before that, we'll just discuss about the water molecules and this structure, basic structure what we have studied. So here oxygen will be having sp3 hybridization. As we said, oxygen will have 8 electrons, 2,6, where here in 2,6 will be having 1s2, 2s2, 2p4, right? So it requires 2 more electrons. So these 4p orbitals will react with the s1s orbital, and you will be having 3p orbitals. This s and this 3p orbitals will combine together and redistribute themselves to find the sp3 hybrid orbitals. That means s orbital will have 2 electrons and p will have 4. So it will recombine and redistribute. So here the hybridization takes place, sp3 hybridization takes place for oxygen, and it will be having 2 half-filled sp3 orbitals. If you see here, we can find these 2 are half-filled, where this is completely filled p orbital. Likewise, you will get the 2 sp3 half-filled orbitals which requires 2 more electrons, and it will be derived from other elements. It will be taken from other element or shared with the other elements. Here in water or hydrogen peroxide, we are taking hydrogen. So hydrogen is sharing 1 electron with it, such that even hydrogen will get the stability. So when 2 half-filled sp3 hybridized orbitals of oxygen will bond with hydrogen to form sigma bond. So these bonds also we'll learn a bit later. So we'll be having pi bonds and sigma bonds. Here the head-on overlap will be called as sigma bond. So head and tail, you will be having thus p orbitals. This will be called as sigma bond, whereas if it is laterally overlapping, this will be called as pi bond. Okay. Now here oxygen is bonding with hydrogen to form sigma bond, while the other 2 contain the lone pair of electrons. We said you, right, when we have oxygen, So here these two have two lone pairs, whereas this is oxygen, sp3 hybridized orbital, and here one electron. So here hydrogen will bond and share with other electron, and hence we get the bond as like this, right? So while the other two contains lone pair of electrons. So what happens? The expected angle between hydrogen, oxygen and hydrogen, this should be around 109.5 degree or all near to that of 109.5 degrees, but it is not that. Experimental value is 104.5 degrees because of electron-electron repulsion. So this is because we have repulsion between the electron lone pair repulsion, and bond pair repulsion. What do you mean by lone pair and lone pair? Whatever the electrons we find here, we say no, this is the lone pair repulsion, and here what we have, the bond with the hydrogen, this is the bond pair repulsion. So here if you see, bond pair repulsion is lesser than that of lone pair repulsion. So what happens? They will repel here than that of the bond pairs. So we get the bent structure with 104.5 degrees. Hope you understand this, students. Good. So you can see this is the structure of water molecule, where you will get 104.5 degrees, and the bond length will be 95.7 picometer. Next, we have hydrogen peroxide, which is non-polar planar. It is a non-planar molecule. It is not in same plane. Where if you see this, it is on same plane, but this is not on same plane. It will be in opposite plane. If I have oxygen like this, and the hydrogen is this, it will be in opposite planes. They are in other planes. So it is not in a lone pair, like it is not in a same plane, non-planar molecule. And we have this dihedral angle between them. Two planes will be having the angles. If I take, this is one angle, this is one plane, and this is one plane. Oxygen is here and one hydrogen is here, the other is in the other plane. So this dihedral angle, that should be equal to 111.5 degrees in gas phase, whereas the angle here will be 94.8 degrees. As we have already seen, in solid phase, this angle will be decreased. Okay. So here the angle OOH means this angle. Okay. You can take either this angle or this angle. That is 94.8 degrees. This is where we have the structure of gas molecule of hydrogen peroxide. You can see it will be having the oxygen-oxygen bond, oxygen-hydrogen bond, where this oxygen-hydrogen bond is 94.8 degrees, and the bond length between oxygen and hydrogen is 95 degrees, whereas oxygen-oxygen is 147.4 picometer, and the dihedral angle is 111.5 degrees. Next question, students. What is the difference between term hydrolysis and hydration? As I said, hydrolysis, lysis means breaking. Hydration, to add up with. Okay, we'll just check what exactly we have. When hydrogen, like H plus ion or OH minus ion of water, interacts with anion and cation of the salt respectively to give the original acid or base, then the reaction is called as hydrolysis. That means if I have water molecule, this water molecule will be broken down into H plus and OH minus ions. These ions, when we add the salt to that, for example, NaCl if I take, just an example. So NaCl, we have Na plus Cl minus. So what happens here? Na will react with OH minus and H will react with Cl minus. Then we get NaOH plus, what do we get? NaOH plus HCl, right? Are you getting this point? I'll just rewrite this. So water molecule will be splitting into H plus plus OH minus ion, and this water, whatever we have the ions in the water medium, when added with the salt, Na plus and Cl minus plus H plus OH minus, we get this OH which has been reacting with Na and H plus with Cl, we get HCl plus NaOH. That means when the salt is reacted with the water, what does it give? It gets back the acid. HCl is acid and NaOH is a base, right? It's a base. So when H plus and OH minus ions of H2O, H plus and OH minus of ions of H2O interacts with the anion and cation. Na plus is cation, Cl minus is anion of a salt. NaCl is the salt of a respective salt, will give you original acid. What is the original acid and base? That is HCl and NaOH, and that reaction will be termed as hydrolysis. Hope you understand this. So it results in the change of pH of the solution, obviously, because when the acid is being formed and base is being formed, it increases the, or it will be altering the pH level. pH means potential of hydrogen. So when water is added to ions or molecules to give hydrated ion, now it is hydrated ion we are adding, or a compound, when reacted we get hydration. Hydration means when you have a molecule, for example CuSO4 I'll take. This is in white color. CuHO4 is in white color. I add the water molecule to that such that this converts into CuSO4 blue color. That means here we have 5 water molecules which has been crystallized with the copper sulfate. So the attach of, or the attracting of the water molecules, or having the bond with the water molecules with this salt or any of the compound or molecule or ion, will give you the hydrated ions or molecules or compounds or salts. So it is a best example where copper, it will be white in color. When it is been hydrated, pentahydrated copper sulfate will give you blue color. So this exactly gives you the definition. When H2O, that is water, is added to the molecule or a ion, it gives hydrated ion or molecule, and that process can be called as hydration. Next question, how can saline hydrides remove traces of water from organic compounds? We know organic compounds are the compounds which are made up of carbon, right? So how does they remove the traces of water from organic compounds is the question. Saline hydrides. So just check it out. So as we know, saline hydrides are nothing but metallic hydrides. So here sodium hydride that releases H plus ions and Na plus ions. So as they release H plus ions, they act as a strong base. Which base we call it as? If they are releasing H minus or hydride ions, we can call them as Bronsted bases, where water is the weak Bronsted acid. They combine with water to liberate hydrogen gas. As we know, this H minus ion reacts with H plus ion in the water molecule and produces hydrogen gas. So saline hydride, that is the metallic alkali hydrides, reacts with water to give alkaline solution or sodium base, we can say. Sodium hydroxide is the base. It gives you base with evolution of hydrogen, and as a result these hydrides can be used to remove the traces of water from organic compounds. That means whenever we have organic compounds and water is mixed in that, if I add this saline hydride, what happens? That reacts with water. So water present in the organic compounds can be easily utilized and we get base with release of hydrogen molecule. Next question. What do you mean by the following terms? So what do you understand by the terms? The first term is hydrogen economy. So this is nothing but the energy which is being transported, right? So the energy is transported or stored in the form of liquid or gaseous hydrogen in principle due to the hydrogen is considered to be possible source of clean energy. Why do we stress on clean energy? Because it will not produce any of the pollutants. So it can be easily stored, easily transported in form of liquid or else gaseous hydrogen. So we use this as a hydrogen economy. This proposal to use hydrogen as a fuel is called hydrogen economy. And next, hydrogenation. What do you mean by hydrogenation? The process of addition of hydrogen to unsaturated hydrocarbons. We know, what do you mean by hydrocarbons? They are the alkanes, alkenes, alkynes. So in that unsaturated hydrocarbons are multiple bonds, either carbon-carbon triple bond or carbon-carbon double bond will be called as unsaturated, and to convert them into saturated, that is carbon-carbon single bond, we are adding hydrogen. So hydrogenation, addition of hydrogen will be called as hydrogenation. So I repeat, the process of addition of hydrogen to unsaturated hydrocarbon is called as hydrogenation. We have the example here, ethene, double bond carbon atom will be present when it is been added with the hydrogen. Directly you cannot. We require the catalyst here. So what is the catalyst we are using? Nickel, palladium or platinum in presence of hydrogen and at a particular temperature 473 Kelvin. As I have already told you, when we have the palladium or platinum or nickel, what happens when hydrogen molecule comes and sits on the surface? They form a weak bond with the palladium such that this strong bond between hydrogen atom will be removed or cleaved. When it is been removed, this hydrogen, single hydrogen can be easily used for addition of hydrogen in this double bond such that the CH3 is formed already. CH2 is there. This bond will be broken and one hydrogen will be added here, other hydrogen will be added here. So we get ethane. Ethene is converted to ethane through hydrogenation, and we have ethyne, carbon-carbon triple bond, which is leading to ethane. Here we are giving 4 hydrogen atoms which has been added to the ethyne. Next, syngas. What do you mean by syngas? The mixture of carbon monoxide and hydrogen is used for synthesis of methanol, and the number of carbon compounds or hydrocarbons, and that's why we can call it as synthesis gas. The gas which has been used for synthesis of many other compounds, and hence we short it form as the syngas. Nowadays, syngas is also produced from sewage, sawdust, scrap wood and newspapers, etc. What do you mean by water gas shift reaction? So here we have the production of dihydrogen. The production of dihydrogen can be increased by reacting carbon monoxide of syngas mixture with steam, as we have just studied about this. So what happens? The carbon monoxide reacts again with water to produce the hydrogen in presence of ion chromate. As to increase the yield of hydrogen, we are using this carbon monoxide to react with water in presence of ion chromate at 673 Kelvin. So this reaction of shifting, this is called as water gas. So this shifting is called as water gas shift reaction. Next, what do you mean by fuel cell? It is a commercial cell which is the chemical in which the chemical energy is being produced during the combustion of fuel and is converted directly into the electricity. It's so simple that this fuel cell is commercially used, and here chemical energy is being used in terms of it is being transferred or converted into electrical energy by combustion of the fuel. So hydrogen and oxygen fuel cells will be utilized, or we generally use this hydrogen oxygen fuel cell. A fuel cell is also used for source of electrical energy in the space vehicles. Next question, what causes temporary and permanent hardness of the water? Temporary hardness of the water is due to presence of magnesium and calcium hydrogen carbonates. You need to remember, it is due to magnesium and calcium hydrogen carbonates. You can also call it as bicarbonates. Okay, and it can be easily removed by boiling. As we know, it can be easily removed by boiling. This temporary hardness can be removed by boiling. Permanent hardness, it is been due to the presence of salts of magnesium and calcium salts, but not bicarbonates, but chlorides and sulfates. So the dissolving of magnesium and calcium, sulfates and chlorides will form the permanent hardness of the water, and it cannot be easily removed by boiling. Last question, discuss the principle and method of softening of hard water by synthesis ion exchange resins. So here hard water is made soft by very common ion exchange resin method. What happens here? The water is being allowed to pass through zeolite bed. This is important. Sodium aluminate, aluminum silicate with hydrated salt, that will be called as zeolite, and this is passed through, the hard water is passed through that zeolite, and during that sodium ions will be displaced from the calcium and magnesium ions. Hence we can easily remove that molecule from the water. So we directly take this as sodium zeolite, which is reacting with calcium or magnesium. They displace the sodium. Even you can see this, it is displacing the sodium, and this can be easily removed out. When whole of the sodium is been, that sodium ions of the zeolites have been exchanged completely to all the two sodium is been exchanged, then you can again regenerate it by treating with the strong NaCl. That means the zeolite can be regenerated by adding salt to that. So if you have this, you can just take reacting with sodium chloride, and again we get the synthesis of this zeolite, and we can reuse it by removal of this magnesium or calcium outside that of water. So this is how the ion exchange resins will be used for reducing the hardness or permanent hardness. Hope you understand this, students. By this is Shruti. As we said, if you have any doubts, students, by this we are just ending up with this chapter. Next we are coming up with the S block elements. In S block elements, in 11th standard you will just study about the basic things with 13 group and 14, 15 group, whereas in second PUC you will continue with 15, 16, 17, 18 groups. Hope you understood this, and the exercise part is very much important, students. We Vistas Learning always be here to help you with your studies. If you have any doubts, you are always welcome to ask any of the doubts regarding this subject.